everyone, welcome to another event under the initiative GDG Tech Sessions. Here, Carlos Gabriel from GDG Madeira introducing this session for you. And with these presentations, we intend to keep sharing knowledge about diverse tech topics from speakers around the world and make it available independently of where you are. So we are glad to have you here, and we hope that you enjoy a lot that we've prepared for you. So what are the main goals of GDG Tech Sessions? As all we know, due to the constraints felt global due to the new pandemic, we are forced to change the way we share knowledge with our GDG community. And now, instead of having in-person events, we are trying to adapt to a new format of events, namely online events. However, this comes with a significant opportunity. At this moment, and with this initiative, we can share even more content for our entire GDG community, regardless of their city or country, altogether in a series of events previously scheduled for everyone. And yes, of course, anyone can join us. So if you are interested in integrating our team, please visit our webpage, and so you can know what you must do to join us. Today, we have in the GDG Tech Sessions counts with the collaboration of the GDG Coimbra, where we will be going to discuss the brand new Android 11 released a few days ago with Carlos Mota and Ricardo Costeira. So about the GDG Tech Sessions, before we start the session, so if your community also wants to propose a tech session, just fill this form and we'll contact you to further details. So don't forget that you can always propose an event with more than one GDG, and isn't mandatory that the speaker belongs to that specific GDG. It can be from your community or a friend of yours with content and skills to share. And these tech sessions can also be proposed for any GDG, any women tech makers, or any GSC that has some content to share to the community. So right before we start the session, we will use the Slido platform in order to facilitate your communication with the speakers. Post your questions and they will reply it at the end of each talk. Like before, the link for the Slido is in the description of this video. Now, with you, Carlos Mota from GDG Coimbra. Hope you enjoy it.
Hello all. Welcome to these second tech sessions. Let me just share my screen now. I believe you're all seeing this first screen. So, hello, my name is Carlos Mota and I'm from GDG Coimbra. You can find us online at Twitter GDG Coimbra, Facebook GDG Coimbra, Meetup GDG Coimbra. If there is a social platform over there, just add GDG Coimbra next and we'll most certainly be there. So GDG Coimbra and GDGs stands for the Global Google Developers Group. And it's a global movement. You can see this picture was taken on the 2018 gathering of all GDGs. And currently, we are scattered all over the world. This is the numbers from today. I took these numbers from meetups. And we are completely surrounding the entire world. Only in Portugal, we are 10 different GDGs. We've been creating events since 2017, if I'm not mistaken. We've done game jams, we've organized Ashcode with the University of Coimbra, we've organized workshops, tech sessions. We have a program called GDG Kids where we teach 5-year-olds how to program using Lego Mindstorms and to solve Rubik Cubes. And we have a yearly event called the DevFest Coimbra. We had our 4th edition last year that had more than 500 people. This is the venue that we have. And we also have the next event already scheduled. It's going to be focused on AR. We're going to have Christina with us, and it's going to be at the end of this month, 29th of July at 17 set. If you're listening from Portugal, or if you're seeing from Portugal, this means that it's at 6 p.m. Lisbon time. As Carlos already mentioned, this is the Slido link. So grab your devices, point the camera here and take your best shot just to make me those hard questions at the end. Or just to complement this really cool talk. Hopefully this icon. So let me just move to the presentation. Hello, once again, and welcome to this Scoping the Scooped Storage. Triple S is here. So, hello, my name is Carlos Mota. You can find me on Twitter at Mota. I've scheduled a couple of tweets to try to make here a live tweeting session. Let's see how this plays out. I've been programming for Android for the past 10 years. I've also been playing a lot with Kotlin multi-platform for the past 1.5 to 2 years. I'm the founder of GTG Coimbra and co-founder of Kotlin HIIT. Also, if you have a talk that you really want to share, talk with us. I've been writing. I am a podcaster wannabe, let's say. Wink, wink, Ricardo. And I love to travel, photography, and running. And lately, of course, only these last two. You can find all the materials that I'm going to give on this talk on my speaker deck and the source code on GitHub. I've also tweeted these links so it can be easy for you to just click there and access everything. So let's start and talk a bit about scoped storage. And I want to make a challenge here. Let's open our file explorers and go to the internal storage and see the number of folders and files that we've got there. This is typically what happens on a brand new phone. I had just installed Android 11, I erased everything, and I have here a couple of folders. Now this is my main phone, okay? I have a lot of folders. I had to decrease the font sizes to show everything. And I have to say that from time to time, I usually clean all these folders because I end up receiving those Android notifications saying that I'm run out of storage. So let's see. I made an Instagram video once, so I'm clearly an influencer here. So I have a cached folder for Instagram. I have this storyboard that I have no clue what this is. Also no clue, probably a cache. Well, this app no longer exists, but all the installed files were left behind. I also have no clue about what this is. And this folder just sounds fishy. It's a backup, but I have no clue which folder made this backup. If I go inside, I have just a base 64 file that I have no clue what it represents. So I've deleted it. And this was my file storage when I first opened the app yesterday. So I wanted to make a challenge here. Let's try to see if I manage to convince anyone to tweet their files to their file explorer. So just go to Twitter, put the hashtag no more scattered files, and let's see who has the biggest garbage files on their device. If everything plays well, I think my tweet just was launched with mine. So let's see if I'm not the only one. It's a challenge. So why is this important? Firstly, as you saw, there is a lot of files scattered throughout your disk. Files from uninstalled apps that were just left behind, and they are there until you decide to manually delete them or you erase your device. It also has some serious problems. For instance, when you grant access to the read and write storage, when that runtime permission is granted, you basically have access to almost all the files that you have on your disk. So this means that malware applications can try to get the EXIF information from those files, from those images, and know where you live, where you work, where you've been to. And this is amazing if you open the gallery and see all those pins on the maps. It's really dangerous if it's a third-party app that has access to it. And of course, they could hypothetically copy things. There's also no clear distinction where files should be stored. We saw that Allo created a folder. There are other apps that store those files on pictures. There are even applications that decide to create their own images folder that say images and then put a subfolder with their app name inside. So the files are all scattered throughout the disk. On some operation use the full path, another use URIs. There is no specific way to access the files, and you end up doing a lot of hacks. For instance, if you don't want to show specific media, or no media file, that sometimes you need to remove it because then the system is unable to scan an upper folder, and then you need to send the full media scanner intent. So some apps can listen to that folder, and some apps don't listen to that folder and don't show you anything. Some apps listen and add to files, and we've got a lot of problems like to be that. I can say that I already faced a lot of them. But thankfully, with the Media Store API and the SAFT and this new implementation, things are way, way better. So let's just see a small timeline of everything. The SAFT in the initial version was introduced on Android 4.4, and Android 6 we had runtime permissions. This means that previous Android 6, you only need to declare permissions and manifest, and as soon as the user installed that app and the app is installed, everything was granted. Yes, I'm this old. We faced that. It was really difficult for the user to know what the app was really doing. And thankfully on Android 6, they fixed this. On Android 7, we had a file provider and then a security over sharing files. And now we have scoped storage. Some key concepts here. So we no longer rely on file paths, but you rely on URIs. Files disappear when your app is uninstalled unless you save them via the Media Store and the SAF. The Media Store API is way optimized and it's really your friend. You can easy access to image, videos, and audio. And if you need to access anything else, you just use the SAF. And now files are secure and private as they should always be. I've got here a simple table. This is really important because I usually end up seeing a lot of applications that don't take advantage of this. Basically, we have two types of storage. Let's say we've got internal storage for the app that it's app specific and no one can access. And you should use it for saving sensitive information. For instance, some kind of configuration that we receive from server, some specific information that will disappear once the app is uninstalled, and no one can access that information. Typically, this is under data user and your package name. You also have the chance to use the storage, the shared storage for your own app that's under storage emulator, your app package name, that also doesn't need permission, and any app can access, but when you uninstall your app, this data is removed. If you use these two, you don't need to declare any type of permissions. If you want to access and store media, you should do it via the Media Store API, and then here you need to request read external storage or write external storage if you're using a device that is slower, API 28. For other type of files, you can just use SAF. Basically, it will call the file picker and the system file picker, and the system file picker will automatically grant you access to that file, and you don't need to declare any additional permission. So it's really important to know where to store files. And remember that asking permissions to the user, it's always a bit suspicious. And when you see that, for instance, an application that typically won't use storage is asking for storage permission, well, there are a lot of applications on the store, let's say. So let's build a gallery. I've decided that the best way to show this concept of scoped storage was to build an app from scratch, and which best way to implement an app that deals with files than a gallery. And this is the application that I've built, and you can see it on my GitHub. Basically, here I'm listing all the files. I'm filtering by video, started and trash. Started and trash are only on Android 11. And now you can see that I'm going to add a specific photo to start, to the favorites. When I access start, there it was. Now I'm going to convert this image to black and white. Since this image wasn't created by my app, I need to ask specific access to the user to make an update on that image. Now there is trash. Trash, it's different from delete. When you add an item to trash, it's similar to what you do on your computer. The item stays on the recycle bin, let's say, and it's there for 30 days. After that, it's deleted. As you can see here, we are now deleting 5 files, and those 5 files won't be on trash. More operations. Now we're going to save this file in a specific location that's not image or the pictures folder, let's say. we decided to give it a specific name. We've done this via calling the system file picker, and here we are accessing information about this image. So let's build a gallery application. These are just the steps that you need. A long time ago, there was a way that we used to iterate over files on our file system. I know that MediaStore API exists almost since API 1, or if not API 1, but it had some limitation at the time, and the best way was to basically get external storage directory in order to get the root folder from our files, and then basically we were iterating over every file, every subfolder, everything. And this operation was really heavy, and it didn't guarantee that any other application had updated the file. Fortunately, this is now all deprecated, and we've got that MediaStore API that we showed. It's now mandatory that we use it. So we also had to automatically see if a file was an image or a video, and now with MediaStore this is given for granted. So let's see a small query. Here what I'm doing is I'm going to access all the image on the device. I've needed to create a projection. Basically what I'm defining here is I'm selecting which columns from the table images that I want to access. In this case, the ID, the path, the display name, the size, and the data modified. I could also access the width, the height of an image, anything that is available. It's also worth to mention that if I wanted to access the videos, for instance, instead of accessing mediastore.images, I would access mediastore.videos.media. The same thing for audio, mediastore.audio.media. So it automatically will change tables, and you'll understand where the request should be made. Now I'm just going to use the content resolver to make a query, and I'm going to say that I want the most recent files first. Yes, the most recent first. I could create other things here. For instance, let's imagine that I want the favorites. I could just send this instruction that I only want all the images that are considered as favorite, and automatically what I return is a cursor with this information. So when I have the cursor, I will iterate over it to have access to all those images. Fortunately, these are now deprecated, and we cannot access the data column because it represents the file path. I know. But truth to be said, on scoped storage, the goal here is to use them via URI, that is as an increased data security and not via direct file paths that we can easily manipulate. So let's build a gallery that's ready for scoped storage. So accessing files, previously, you only need to ask for read and write permissions, and once the user gave it, your app could have access to almost all files. With Android 10, scoped storage is enabled by default. This means that if you want to have the previous behavior, you have to set a request legacy external storage flag to true. This means that you will still have the previous behavior on Android 10. When your app targets Android 11, this will no longer be possible. So we'll need to implement scoped storage. There is, although, a flag called preserve legacy external storage. That means that if you install if you update your application that is already installed, and if you launch that update targeting Android 11, you will still have access to the files that your app previously created, meaning that you still can access them without asking for user permissions. Of course, when you uninstall the app, if you decided to install it, once again, you no longer have access, and scoped storage is now full. So let's see how we can list files. We were talking about the MediaStore API, but we notice that these are now deprecated. So how can we overcome this? It's really simple. We just need to remove the data, and instead we're going to use content URI with append ID that will give me the URI for that file. And we're now scoped store approved. Media location. This is really important, once again, because images have a lot of metadata that can say where a people has been, or where a people is, or a person is, where a person has been, or where a person is. So we want to keep this information totally secure. And this information, of course, can be the home, the work location, where he's been to. Previously, you would access this information via the path and by just calling exit interface. But, well, remember, there are no paths now, so you need to access via URI. So we're just going to use the media store. We're going to have the URI to call it from our content resolver, and we can just call the exit interface from there. Or can we? We can't. We can't because this is really sensitive information. If you do this, you will receive an error. Your application will crash saying that it's a non-supported operation exception. You'll need to define the access media location flag on your manifest, otherwise you won't have access to it. So we will make a simple request for permissions. You need to ask for the user permission to accept it. Once granted, you can access to it. So what this printed is these coordinates, and if you're really wondering if this is where I live, most of the times, yes. Hopefully everyone will meet me in 1 hour at this grill bar, but this is where I really like to live. Sorry, I had to add a Kotlin joke here. This time no ketchup, so I just needed to search where Kotlin really is. Create a file. Create a file, you guessed it, it's done via the Media Store API. It can be stored in pictures or the sim folder. And of course, you can add a subfolder inside pictures or inside the sim. This is totally up to you. Previously, we do something like just call file.copy2 and you say the location of a new file and automatically everything was created. Of course, you needed to do this awful thing that was to send this scan file broadcast, where applications would listen to this broadcast and make a new request to add your file to their list if they were a gallery application. Unfortunately, this makes no update on the media store table, so if you're querying, you won't receive all the information that is related with a file. And this also means that you could create any file anywhere on the disk. So let's put this under the scoped storage concept. We're going to use the media store. We're going to get where we should save that file. We're going to define the values on the media store table. And I'm just defining this for here because it's a lot of code, but of course you could define 10 or 20 more values, and you should define the sizes, the width, the height, everything. We're then going to insert it on the table. We're going to compress this image in order to save it. And if you saw here, there is a spending attribute that it's a bit weird. This attribute is used for the time that you're still doing the save operation. This means that this file will be ready in no time, but it's useful to notify gallery applications, for instance, that the file is being processed and you shouldn't read and write at the same time. Once the process ends, we put this value at 0 and then we update it, and we're once again ready for scoped storage. Of course, we can define a specific location for storing an image. We're going to do this via the system file picker. As you can see here, I'm just going to store it temporarily on the root. And you can see that it was called hello.jpeg and it's saved. So this is fairly easy to do and really simple. We just need to to create an intent with action create document and then define the file name that we want to show and to save, and of course the media type that we want to save that image. After that, we're just going to call start activity for result because we need to have the URI with the right permissions for where we can save the file. So if the user selected a specific location, we'll then receive the URI that it's inside data.data, and we can save the image on that specific location. It's important to mention here that if you're giving access, this access is lost when you first stop the application. For instance, if you want to save on that same location, you need to make to ask the user to make the same process. Let's updating media. We have two different scenarios here. We have the scenario where our application creates the media and we can easily access and modify it without any problem. And the moment where we are accessing a file that was created by other application. For instance, on our gallery application, they are accessing an image that was created by the camera, a photo that the user took. So basically, let's imagine our use case. We're going to save these images black and white. what will happen if we are going to do this on an image that was taken by the native camera is that we're going to have an exception. We're going to have a security exception because we're trying to modify an image that wasn't created by us, and under the scoped storage rules, this can't be done without the user acceptance and granting this permission. What we're going to do is just get this action intent, the intent sender is in action intent, and we're going to ask the user for permission to change that image. You'll then see a dialog that he will grant or no the permission to modify that image. Let's see the example now where we're going to delete media. Once again, things are really similar. We just change the different method, as you saw the dialog here on the video. So, and you don't need to send notification broadcast. Media Story API does everything for us. So if you want to delete, we just call our context resolver.delete with the specified words that we want to delete. As an exception is thrown, and then we're just going to call the start intenter for result with this permission, and it will automatically be granted. It will be granted by the user or not. So what if we have multiple files we want to delete? Yeah, it's not the best experience, right? You need to manually ask for each one of these images that you want to modify it. So what's new in Android 11? So although scoped storage is already available on 10, there are a few changes on Android 11. For instance, Action Open Document or Action Open Document 3 no longer give you access to some root folders. For instance, Android Data or Android OBB are now blocked. The same thing happens to the root folders of internal storage or SD card. Also, if you try to gain access to the downloads folder, this is now also blocked because you can have some sensitive information over there. You can also use file paths now on native libraries. This support has been given. It basically, file paths API will delegate over the Media Story API. You have the concept of bulk operations and now start and trash categories. So bulk operation, it's just to give you a better UX. You have one screen that shows all the media that's going to be accessed. Let's see the same example where we're going to delete a couple of images. Yeah, we now can see that we have a single dialog that you can grant permissions to all images. How can this be done? You just use the media store once again, create a delete request, and then start intent sender for a result with that intent sender that you receive. It's important to mention that this is available on Android 11. So if you run this code on Android 10, your application will crash. Now let's imagine that we want to start an image, we want to add an image to favorites. So basically, you just you're going to select an image here to add to favorites. For instance, you want to show image with important first. So you're going to do the same process. You only need to create your favorite request with a URI, and this state here means that you want to add it to start. So it should be true if you want to add it, and remove it, it should be false. We're then going to send the start intent sender for result, and then usually be prompt to add it to favorites. Once again, it's only available on Android 11. Let's talk about trash. So trash, as I was mentioned before, it's like the recycler bin, and it will be automatically deleted after 30 days. Yes, selecting and moving to trash. And we follow the same approach as before. We create a trash request, and then we call the start intent sender for a result with the intent sender that we received on add to trash. Once again, this is only available on Android 11. There are a couple app exceptions here. Let's remember that we have file manager and backup applications that need to access to the entire file system. So how Google tried to overcome this. First, you need to declare a specific permission called manage external storage. When you declare this permission, you also need to declare an intent, and the user needs to manually trigger this intent, and you need to give access from your application. So basically, it will show a similar screen to this one, and you will say that this playground app, that's the one that I created, will have access to all the files. Also, Google Play needs to, of course, to accept your application and check that you're not doing anything that you shouldn't. Migrating files. This depends a lot on your application. Remember, the key point here is that users shouldn't lose their app data. It depends a bit on the application, and some advice is you can request still legacy storage if you're targeting Android 10 and start the migration process on Android 10 updates. You can also call the preserve legacy storage for an installation when you target Android 11. And of course, on most cases, you might need to rethink your UX because now you have a step where the user needs to give access to your application. Some final remarks here. Scoped storage is mandatory when target Android 11. There is no way to opt out. It can be disabled on Android 10 via request legacy storage, so you need to redesign your app to use these appropriated folders. Don't forget migration. Once again, it's really important that users don't lose access to the files that they are already familiar with. Use the Media Store API for accessing image. Don't forget that you'll need to ask for permission if you're accessing and trying to modify an image that your app didn't create. Use the SAF not for images, media, and views, but for the other files. And once again, remember that if your application didn't create that file, you'll need to ask permission. These are some useful links about storage that I invite you to, after this talk, to look out. Of course, you can always reach me on Twitter or ask me something directly. And the source code is on Scoped Storage. And that's all. Thank you. Let me just now look at the amazing questions that you all made. Okay, I just have one question. So I'm assuming here that everyone loves this presentation and doesn't have questions. When you use an emulator like BlueStacks and give permissions for memory, etc., do you have access of my disk C //? This is a good question, Francisco. So I have to check this, but I think we're talking about different things here. You're asking for memory permissions. I'm talking about file storage permission, and I'm not sure what you mean with C2.//. Any chance you could give that information on the YouTube chat, just for me to understand better the question? If you're talking about the root folder, I can say, if you're talking about the root folder, I can say that you won't have access to it. The only way that you could have access to any of those files is that you use the system file picker, and manually the user needs to select the file that he wants to access. Otherwise, you won't have access to that root folder. And this behavior, it doesn't happen only on BlueStacks, but it's common to the emulators and the devices. I have another question. So to activate the usage app permission under 11, it's done in the same way. Yes, the user needs to manually say that I'm going to authorize your application to have access to information that it shouldn't have. There are special cases for that. More questions? I think you still have 1 minute for questions. This is also good to create some stress over Ricardo that's going to talk next. I'm betting that he is all now stressed out. So thank you all for being here. Once again, if you have any questions, please just ask me, that I will answer in no time. So thank you all for being here. Oh, so close. So does permission to strike apply for file permissions too? Permission to strike? Okay, I'm thinking that this is a joke. Any comments on YouTube? I don't have access to the chat that I could see. Okay. I have to tell people that I'm listing the question on YouTube chat. So can you please? Oh, it's the same question? Okay. So no more questions. If so, okay, thank you all for being here. And it has been a pleasure on my side. So I'm going to tell Ricardo that it is time to shine.
Okay, hello all. For those of you that just joined now, welcome. My name is Ricardo. I'm an Android engineer at Mindera, and today I'll be talking about data access auditing. So again, if you have any questions, just go to slido.com, use that event ID and ask away. So before diving knees deep into data access auditing, I want to start with this hypothetical scenario where your team has an app idea. So this app idea is called Run Believable. It's your usual running app where you get to your starting point, you start your timer, you run until you can't just not run anymore. You stop your timer, then the app will use these really super high-end complex machine learning algorithms to improve your running technique. And you can even boast about how fast you are on Facebook. So as you start developing this and figuring out exactly what features you should have, it's one of the first decisions that you have is that you actually need user location. So in order for the user to use your super advanced running tech, he has to give a little bit of his privacy to you and actually allow you access to his location. And since you so eloquently and simply explain why, users just grant you access. So you start developing your app, you have features and new features, and time just goes, and well, your app rocks. Everyone loves your app, everyone loves running thanks to you, and those that don't love running actually hate you because their Facebook feed is flooded with annoying and unbelievable progress reports. So there's 5-star reviews everywhere, and you start noticing that 7 out of 10 reviews actually mention the exact same thing. So everyone's talking about this high-intensity interval training feature. So, well, basically, people just after running, some people just like to do some kind of high intensity workout to just finish off those last reserves of energy. So you start figuring out what would you need to a feature like this. You would need an exercise list, you would need exercise descriptions, default workout plans, workout builders, timer for exercises, and everything else that you will only remember when it's already too late and you have to refactor the whole app to fit it in. So there's one thing here that I want to mention in specifically, which is timer for exercises. Well, you already have a timer for running, right? So why not use it? So you reuse it and you ship your feature out. So time goes by, people that already used your app love it. They love the new high intensity interval training feature. In fact, they love it so much that they start recommending those friends that really don't like running to use it. And some time goes by and this starts to happen. So first you panic because your unbelievably record of 5-star reviews is now flooded with 1-star reviews. And second, on the second stage, you go read them and you actually have no idea why everyone's complaining about location, because it's a high intensity interval training feature. It's not supposed to require user location. So what happened? Well, remember when you reused the timer? Yeah, for some reason that I'm sure at the time made total sense, the timer requests user location. So how would you prevent this? I mean, you tested your app, your QAs tested your app. Of course, they forgot to uninstall the app and install it again to check if new permissions were being asked, but it happens, right? So this is where data access auditing comes in. So data access auditing basically allows you to track access to private data. And here, and for the rest of this talk, when I mention private data, it's actually data that's gated by either runtime or AppOps permissions. So location, contacts, microphone access, the works. And so it does this by allowing you to register a callback on any Android component. So that's the callback. And it has a bunch of features, and the coolest ones, at least for me, is that it can provide the actual stack trace from the thread it's called if the call for permission for private data access is synchronous, and it can do that with third-party apps, third-party frameworks, which is really cool. Okay, so wish me luck. I'm about to do a live demo. We all know how these usually go. So here I have, it's a simple sample app that I've built with Android Studio. I just added a few extra stuff. So here I have an object auditor. This is where I'm actually registering the callback, the on OP noted callback. So the thing to notice here is that the callback has 3 different overrides: on noted, on self-noted, and on async noted. So on noted will be called whenever the data access call is synchronous. On self-noted is the same, but it will never be called by the system. It will only be called by yourself if you manually trigger the node op. I'll show you an example later. And on async noted is whenever the data access is asynchronous. So each of these overrides get 1 parameter. These 2 get the same one, the sync node appop, and this one gets an async node appop, which has a different thing from the other 2, and it's this message. So why this message? Because as you can see in these 2, I'm creating a stack trace. Since this one can be called from any thread, it might be that it gets called from a thread where the data access didn't occur, so it's no use in having the stack trace. However, this message will provide some information. So this stack trace, I'm basically just I'm basically just launching a throwable and getting the stack trace from there, because since both of these will be called from the thread where the data access is made, the stack trace will always describe what made that call. So, okay, this is the callback, and to register the callback, you have to get an instance of AppOps Manager, and then set on OP noted callback, and you pass in the callback. This executor, which I'm injecting in the object, is basically the executor that will end up executing on async noted. So in this case, I'm running it here. I'm passing in the main executor. Okay, so here I'm registering in the callback in the application, my custom application. However, as I said before, you can register it on any component. Just be aware that if you register it, for instance, in a fragment, you have to unregister it when you get out of that fragment. Otherwise, as soon as you get in again, you'll try to register it again, and you'll get an illegal state exception. Okay, so I'll start by just a second. This is a beer mug, but I swear it's water. So I'll show you now one example of each of these being executed. The callback is already registered here. So in this fragment, I have a location assistant instance, and this location assistance is one class that I created. It has a bunch of methods to check for permissions, but the thing that I want you to focus in is this one, which is basically an access for location manager to request location updates. Okay, so this is called here. So let me just run the app. Okay, this is the first fragment. We're in the second one. Okay, so, oh, by the way, Easter egg, new Android 11 feature, one-time permissions, which is pretty cool. So let me just give permission. Okay, so now, okay. As soon as I click this button again, now that I've granted that location permission, this will be called. So we should get a log that is captured by the callback. Okay, so here it is, private data accessed. And here you can see a bunch of different information. So we got the operation, which was Android find location. So the data access was for find location. We got an attribute tag, which is null. I'll get back to this later. And here's the message I told you before. Since this is an on a sync node called, we don't get an actual stack trace. So, but we do get this message, which actually is not that, well, it's better than nothing, right? But it basically tells me where the call was made. So it's basically pointing to this method. Okay, so this was for location. This is an on async node. Now I'm going to show you an on-up node, this one. Yeah, the synchronous call. Oh, and by the way, when I'm mentioning like synchronous calls and asynchronous data access, it's not on us. It's not on the way we call it. For instance, I could call this instead of calling in on a callback, I could call it synchronously, and I would still get a non-async node because this internally, the location internally is requested asynchronously. So it's not how we call it; it's how the framework deals with accessing the information. So to show you the unnoted call override, I have here my contact picker, which is a third party. Well, my contact picker is a class of my own, but it calls multi-contact picker, which is a third party framework. So as soon as I click here, it will ask me for contact access, which I'll allow. No, let me just clean this. Since I've granted the permission, as soon as I click this, might as well just show you the. Okay, so set on click listener, contact picker launch. As soon as I click this, we'll get an on node called private data accessed again. Here we have the operation. The attribute tag is null again, but here's the really cool part. We got the actual stack trace of the thread, which basically lets you know what's accessing the data. As you can see here, we can easily identify the component that's trying to access private data. And this is really cool, at least for me. So this is it. So, okay, finally, well, I'm just missing the on self noted. This one is probably the one that will be the rarest one, because as I said before, it's not called by the system. So this one will only trigger when it's called by us developers. And the way to do that is, where's my first fragments here? Okay, I have this do self-sync app, which is a method I created. And in order to trigger the on-self node, you have to manually do a node op. So a node op is done every time private data is accessed by permissions. That's why we get the other callbacks. We're doing it manually. It's a good way for the app to blame itself when it tries to access things that it shouldn't. But to be honest, I'm not really seeing this as being that much used, but hey, who am I? So let me just build this again. Okay, so I'm calling this as soon as I press the button on the first fragment, so this one. And as you can see, on self-node called, you get the operation Android find location, which is the operation I'm passing in here. We get the attribution tag. This one actually has an attribution tag because I'm passing one. I'll explain what it is in a bit. And we also get the stack trace. So it can basically pinpoint where the access was done, which is pretty cool. So yeah, and just on a side note, you have to actually pass the apps, the process UID, otherwise this won't work. It's really contained, so. Okay, what else can I show? Oh, the attribution tag. So what is this, or when it is useful? So let's say that, no, let me just comment this again. Let's say that as I access location updates on the second fragment, now I also want to access on the first fragment. So I copy this here. I have to get the instance. Okay, build. Okay, so now, as soon as I click this, this will trigger, and we'll get the private data accessed. And remember that there's the exact same code on this button. So if I press it, okay, we get the exact same thing. And when I mean exact same thing, it's actually the exact same thing. If, as you can see by the message, it's the exact same message, even the object reference the same. So this is where the attribution tag kicks in. So the attribution tag is actually a way to distinguish different calls to the same private data. So how do you use this? Well, I can just come here and use something that's called attribution context. So this attribution context takes a tag, an attribution tag. Plot twist. So I'll call this second fragment. So basically, long story short, this returns a context. So instead of returning the regular context that I was passing in the regular context that I was passing, I'm passing one created by attribution context. So this will eventually be used to request for, as I'm getting the location manager through this context, this will be the one used to track the private data access. So I'll do the same thing here. First fragment. Put this again. Clean this up. Okay, so now if I press next and I press previous, as you can see, attribution tag, first fragment, attribution tag, second fragment. So now you can actually pinpoint the exact place where private data access takes place. And I think this is really a cool feature if, for instance, you're injecting your context with Dagger or whatever, and you can inject specific contexts to specific features if you want to track how that feature accesses private data. And yeah, that's about it. It's pretty simple to use. So back to the presentation, if I can. Okay. Okay, so do you need this? Well, like everything on Android, it depends. First and foremost, it depends on you. I mean, don't take my word for it. If you want to use it, just use it. But as a rule of thumb, I would suggest looking into your current project and your current team. For instance, if you have a small team, if it's a relatively simple app, even if you don't need that many permissions, I mean, it's probably not worth it. On the other hand, if you have a larger dynamic team with people coming in, people going out, if the project is complex, you need a lot of different permissions, then it might save you. I mean, if the Runbelievable guys have this, it will definitely have saved them from the 1-star reviews. And that's it. That's everything I have for you today. Hope you enjoyed it. I'll check the questions. So is there any way to get the lockout automatically for the assist methods, or do we need to write it on each method as class when you put an app on store? well, you could probably send this to Crashlytics or something. I mean, this is pretty much, let me show you the, this is pretty much, I mean, each of these is calling a log private data access, which basically does a log. So you can do whatever you want with this information. You just inject whatever you want to log here. You can use Timber or to create the different leaves. I mean, it's really up to you. They built this on a way that it's actually pretty easy to extend it. So yeah, you can send it to wherever you want. More questions? Soldier string. So Mota, what do you mean by not ask again by runtime permissions? Can you post your question more elaborate way, please? Right. Okay, I'll wait. Any questions on YouTube? Okay, if there are no questions. Okay, so if there are no more questions, thank you very much. Almost, damn it, you guys love doing this. When app starts, can you activate the audits so that later on accessing the various components views as permission used by interaction? I'm not sure what you mean by interaction. But well, you can, as I said, you can, I mean, I'm doing this here, but I could do it whatever. So you don't need to just have it ready to go as soon as you open your app. So for instance, if I come here, just, I don't know, if you create it, for instance, if I do this, this won't work, do this, this, it will work as soon as I get into this component. Like I said before, just please don't forget to actually look on this. Actually, don't forget to unregister the callback, because otherwise you'll get an illegal state exception. And to unregister, it's actually pretty simple. You just call set on noted callback and pass the parameters and pass null parameters. Also, it's actually a little bit tricky, because if you call set on noted callback with a callback and there's already a callback, it will complain and give you the illegal state exception that saying that there's already a callback registered. And if you try to unregister without any callback being registered, it will complain saying that there's nothing to unregister, so it will return an illegal state exception as well. So be careful when using this. That's why this is why I just place it here, because I don't have to worry about it again. It is okay. I'll do this later. Okay, if that's all, thank you so much for being here. I hope you enjoyed it, and have a great day.
So everyone, I hope you enjoyed. After this event, we have this form that you can fill and give your feedback about this event. And after we receive your feedback, you can win an open badge to add to your portfolio. Also, if you have We are so happy to announce the next GDG Tech Sessions confirmed. The speaker is Romulo Sintra, with an overview around the web vitals and their impact on the actual web, understand how these metrics are used to improve experience and solve performance bottlenecks. The sessions is scheduled for the July 29 and is already scheduled on the website. Don't forget that your community can also propose a tech session. Just fill this form and we will contact you to get all the things ready. Just to end, follow us on our social media to get updated on the last news. Just want to thank all the team that make this initiative possible, mainly to GDG Coimbra, Carlos Mota and Ricardo Costeira in persons for their fantastic presentations. Thank you everyone for joining us. Hope you enjoyed a lot and hope to see you soon. Goodbye.